Hi, sixth graders. So last week we looked at modeling one-step equations, and that was where you took the picture, you looked at a picture and you wrote down an equation based on how many missing objects you see, and then based on how many other individual objects that you saw. And so you practiced doing that. And so I want us to think about a couple of those pictures that we looked at really quickly, because today we're going to start solving them. So if you think about to your last page of notes where we had a missing amount plus 3 is equal to 7 on the other side. What is one way we could figure out how many is missing? Well, most of you thought, oh yeah, that has to be 4 because 4 plus 3 is equal to 7. But what could we do with the number 7 and 3 in order to get that missing amount? So notice how right here, it's like some number plus 3 is equal to 7. What we could have done is we could have done 7 minus 4, or 7 minus, I'm sorry, forgive me, 7 minus 3, which is these two numbers, and gotten the answer of 4. And so in order to solve an addition equation, we could use subtraction to find that missing amount. Now, look at the next one where we had 2 missing objects and 8, apples, I think we called them on this side. So how could we figure out how many apples needed to go in each bag? Well, again, this is multiplication right now. It's 2 times the missing amount. And so what we would need to do in order to get the missing amount is take these two numbers, 8, and we could divide it by 2. There I go writing 4 again. Divide it by 2, and you get 4, which is how many apples have to go in each bag, 4 here and 4 here. And so we find that in order to solve what we would call a multiplication equation, where we're multiplying a number times a missing amount, we could use division in order to solve. And so, without further ado, our next page of notes is going to be called Solving One-Step Equations. And we're going to use addition and subtraction for this page of notes. Now, we'll do a page of notes next video where we're going to use multiplication and division, but today we're just going to focus on addition and subtraction. And so what we find, and what we just talked about, is that we have what is called an inverse operation. Inverse operations. And inverse operations are just math operations that undo. Math operations which undo. If I could spell, undo each other. And addition and subtraction are 2 of those. So if we add, the inverse of that is to subtract. All right, so we're going to keep that in mind. That addition is the inverse of subtraction, and subtraction is the inverse of addition. And we found that when we looked here, right? Because we were adding, but in order to find the answer, we can subtract to find the answer. So today we're going to solve one-step equations using these inverse operations to undo in order to find missing amounts. So no pictures today, we're just going to look at equations. And so we're going to look at least 4 different examples. So if you want to split your paper, the rest of your paper down the middle, we're just going to do an example on each side until we get all of our examples done. Okay, so let's say I had an equation that looked like this. So let's say it was x plus 79 is equal to 105. Okay, so let's say I had this equation, and I know that there's some number out there, when I add 79 to it, I get 105. Now, I could guess a couple numbers, and I could say, okay, what number is it? I could maybe try 50. Oh, no, that doesn't work. I could maybe try 55. Oh, no, that doesn't work. And so I could work my way around to just plugging in a number and seeing if it works. But the quickest way to solve this is to think inverse operation. So what we found a minute ago is if I take these two numbers and subtract, because I'm adding, if I subtract this number away from this number, I will be able to find that missing amount. Now, here's normally how we show our work, and it may seem a little strange to write it this way right now, But this is, again, what we call a one-step equation. Eventually, in other classes, you will do two-step equations and multi-step equations. And so it's important to know how to use these inverse operations. So what I like to do is I like to draw a line through my equal sign to represent a balance. So remember we talked about if something's equal, then this side is balanced with this side. And here's what I'm going to do. I'm going to use subtraction because I see a plus sign. I'm going to use subtraction to take away 79 from this side of my balance. And if I do that, then all I'm left with, if I have 79 minus 79, what does that equal? That equals 0. Now, I'm not even going to put my answer 0 down here because it's gone. But now if you think about a balance, if I took away 79 from this side of my balance, what would I need to do to this side of my balance to keep it even? Well, if I was to remove 79 from this side, I would have to subtract 79 from this side as well to keep it balanced. Now, here's where we use our inverse operation to actually find our answer. Because look what's left on this side. We're left with our x. The only thing over here now is x because we took away the 79. And here's where we're able to subtract to actually find our answer. Now, the good news is that we're able to use a calculator on this particular section of, you'll be able to use a calculator on the test, and you'll be able to use a calculator on the SOL, and it'll be the Desmos Scientific Calculator. So remember, you can access this calculator from the main page on our Schoology site. It should be right underneath the agenda or the daily schedule. You can click on a link that goes to that Desmos Scientific Calculator. We've used this before when we did exponents. So we can use that to actually do this math. 105 minus 79 is what we're doing. So 105 take away, 105 minus 79. And your answer shows up right here. And so my final answer is 26. And so I'm going to write that. I'm going to write it like this. Now, every single one of these equations, we're not just going to write down a number, but our final answer, 105 minus 79, we get the answer 26. And our final answer is not just 26, but it's x equals 26. Because remember, we were trying to find this missing amount on this side of our balance. And so some number plus 79 had to equal 105. It had to be 26. Now, if we want to make sure that we're right, what we can do is if you're telling me that x is equal to 26, I could go back up here and I could rewrite this equation and say, okay, is it true then that 26 plus 79 is equal to 105? Is that a true statement? And so again, you could go back to Desmos and you could type that in. So I'm asking myself, let me zoom this back out, is 26 plus 79, does that equal 105? And it absolutely does here. And so you know that you're right. These are questions that you should never have to ask, Miss Wallace, is this right? Because you can use your calculator to double check it, okay? So let's look at another example of an addition equation. So you might have some negative numbers thrown in. So what if we had an equation that looked like this? What if we had x plus negative 5 is equal to 12. So I want to know, there's some number out there, and when I add negative 5 to it, it comes out to be positive. Actually, let's leave that, positive 12. It comes out to be positive 12. So I want to know, what is this answer? And again, you could spend your time trying to think of, well, is it negative 6? No, that doesn't work. Is it negative 7? No, that would be negative 12. You could come up with you could try to see if you could figure it out, or you could use inverse operation. So again, I'm going to think of this as a balance. So I'm going to draw my line to indicate that, okay, this side needs to be balanced with this side. These sides are equal. And so again, I'm going to look at my operation and I'm going to say, okay, is some number plus negative 5. The inverse of addition is subtraction. And so I'm going to write down subtraction. Well, what am I subtracting? What am I trying to get rid of on this side? I'm trying to get rid of this negative 5. So I change the plus sign to minus, and I'm going to subtract negative 5. Now, that means this is going to equal 0. So again, I've used the inverse operation, and I've taken it away. And you could even check that in Desmos as well, because we should find that it comes out to be 0. Because remember, inverse operations should undo each other. So if I have plus, so again, I could just type in my calculator here. I could just type in, I've got plus, oh goodness, I hit a wrong button. Let's go back to the Desmos calculator. All right. So I've got plus -5, and the negative button on this calculator is found in a different menu, I believe. Oh no, we use the minus sign. That's what we do. So Desmos calculator, the minus and the negative are exactly the same button. So you hit that. So we hit plus -5, and then remember the plus -5, and then we're subtracting -5. So we're actually going to hit that button twice. So we're subtracting now. Oh, I keep going back. Sorry about that. All right. Plus -5. There we go. Minus -5. And the answer shows up. We get 0. That's good. That means I can mark this side out. But now, if I subtracted -5 from this side, minus -5, that's where I'm going to get my answer at. So I need to subtract -5 from 12. So I'm going to back this out. And I'm going to do, okay, it's 12 minus -5. So to find my answer, 12 minus -5. Remember, again, minus and negative are the same exact sign. We know that minus and negative is plus, right? So it makes sense that this comes out to be 17 because it's 12 really plus 5. And so my final answer is going to be, remember, don't just put your number down, 17, but what's left on this side is x. That's our missing amount. Our missing amount is equal to 17. And so, again, you should be able to check yourself by saying, oh, okay, Miss Wallace, I'm telling you that x has to be 17. So that means if I take 17 and put it right where I see my x there, it should come out to be the right answer. So what I'm saying is it should be true that 17 plus -5 is equal to 12. Is that true? And again, you can go back to Desmos and we can type in, is it true that 17 plus -5 plus, again, minus is the negative, is equal to 12, and that is true, and so we know we've got our correct answer. All right, so those are both addition equations, right? And so when we're solving an addition equation, we want to use subtraction in order to find our answer. And what we're going to do is we're going to treat the equation like a balance so that we get it balanced, so that we get rid of the number on this side and we're only left with our missing number, and that we actually get an answer over here. Okay, now I want us to look at a couple of subtraction problems. So draw you a line. Let's look and see, what does it mean to have a subtraction equation? So let's look at an easier example. So I'm going to say some number x minus 19 is equal to 26. So some number out there has to be bigger than 19, right? Some number, when you take 19 away from it, is equal to 26. Of course, you could guess, but we don't want to guess. We just want to find our answer. So I'm going to draw a line down through the middle of the equation, making it a balance. And so I want to get, my goal is to get the missing number by itself. Yeah, my goal is to get x is equal to something. I want to know what x is equal to. Well, right now, we've got x minus 19. So if we had an addition equation, we subtracted to find the answer to make that 0. What do you think we're going to do when we have a subtraction equation? Well, what's going to get rid of minus 19? The inverse of minus 19 is plus 19. And again, you could check yourself and make sure that that makes sense to you. Am I actually getting 0 on that side? And in your calculator, of course, you could say, okay, yeah, minus 19 plus 19 is 0. And so I'm able to, on this side, mark that out. And that's good because that's going to leave me with just my x. So the minus 19 and the plus 19 get marked out, gone. We're left with x, but if we added 19 to this side, of course, we need to add 19 to this side. So we're actually end up adding 26 plus 19. And so again, we can use our calculator, should we so choose, 26 plus 19, and that equals 45. And so we're saying that the missing number, using inverse operations, that missing number, what's left, is going to be equal to 26 plus 19, which was 45. So let's check our answer and make sure that we're right. Is it true then that 45, to plug in for the x, minus 19 is equal to 26? Does that make sense, and does that work? And so we type that answer into our calculator and we say, okay, is it true that 45 minus, what was it, 19? Yeah, 45 minus 19 actually equals 26, and that's true. And so you know that your answer here, x equals 45, is correct. All right, let's try another subtraction one, and then I'm going to give you a couple maybe to try on your own. Let's do one with a negative number in it. So, and actually I'm going to flip it around this time to show you that the x is not always going to be on the, notice in all of these examples, the x was on the left side of the equation, right? Left side, left side. So let's look at one where the x is on the right side. So let's look at, what if you had -7 is equal to x minus -4. Now, sometimes, especially when you have lots of minuses and negatives together, sometimes they will put one of those numbers in parentheses to just sort of indicate that, hey, this is a minus and this is a -4. It's just kind of a placeholder, just sort of showing you that, hey, this is one number right here. But remember, in Desmos, negatives and minuses mean the same thing anyway, so that doesn't necessarily matter. All right, so anytime, again, I see my equal sign, I'm going to draw my line down the middle in order to make it a balance. So I need this side balanced with this side. I want to know what's my missing number. So my goal, even though the x is on the other side, my goal is to get x by itself and to figure out, well, what is x equal to? Well, right now we have x minus -4. We're going to use inverse operations to get rid of that minus -4. The inverse of minus is plus, so I'm going to put a plus right below that. Remember, my goal is to make this 0, so I get x by itself, to get rid of this part and move it over here. So the opposite of subtraction is plus. The opposite of the number that we are adding, or the number that we are subtracting here, is -4, so the opposite of that is plus -4. We don't change the number, we only change the inverse operation. We want to use that same number. And again, we want to check here and make sure that we're getting 0 to make sure that that is gone away so that we can just have x by itself. So what we see is we had minus -4, right? That's what we had here. And if it makes you feel better to put that -4 in parentheses, you can, it doesn't matter. So we had minus -4 on the top, and then we're adding -4 to that. So plus -4. And do we end up with 0? We do. So again, all I did was type in exactly what I see right here to make sure that that's 0 so I can cancel it out. And that's good because I'm left with x, but what I did on this side, in order to keep this balanced, if I added -4 to this side, I also have to add -4 on this side. And so I'm going to do this math. Now that might be something you could just do in your head. -7 plus -4. If not, you could type it in your calculator. -7 plus -4 ends up being -11. So the answer on this side is -11. So again, it doesn't matter that my x is over here. That's my final answer. It still says that x is equal to -11. And so I want to make sure that this is a true sentence. So is it true that -7, I'm just recopying this, but I'm going to put -11 in for x. Is it true that -7 is equal to -11 minus -4? And so I'm going to type this part into my calculator to make sure it does come out to be -7. And so that was -11 minus -4. -11 minus, again, if it makes you feel better to put in parentheses, that's fine. And it does come out to be -7. So this is a true statement. I wanted to know if it's true, and it is. So my final answer is x is equal to -11. And that is what you're going to type in. Most of these is going to, you're going to have the problem. So you're going to have this first line, and the answer will just be x is equal to what? And it'll be a type-in answer where you just type in your number here. All right, I'm going to give you 2 more. I'm going to let you try them on your own, and then we'll go over the final answer, and then you'll be ready to practice. So I'm going to give you an addition. And so remember, to solve this one, you're going to use subtraction. And this one's going to be subtraction. And in order to solve it, you're going to use addition to get the answer very quickly. All right, so let's try one. So for the addition equation, I'm going to give you x plus 7 is equal to -15. And on this side, we're going to do -10 is equal to x minus 5. All right, pause the video, take a second, see if you can figure out how to solve these, and we'll come back and we'll give you the answer. All right, I hope you took the time to pause the video and work these out. So again, remember, we're treating this like a balance. The first thing you should always do is draw that line down through the equal sign to make sure that you're balancing them. And then we look for the inverse operation. So again, my goal here for this first one is to get x by itself. How am I going to get rid of that plus 7 and move it over here? How am I going to make this 0? Well, the inverse of addition is to use subtraction. So I'm going to subtract 7 from this side to keep it balanced. That's 0. Plus 7 minus 7 is 0. And then we're going to subtract 7 from this side as well. Now here's where your calculator should come in. So you're going to type in negative 15. Negative 15, take away 7 more, and that gives you negative 22. And so you want to make sure, is that my final answer? And so is it true that negative 22 plus 7 is equal to negative 15? And if you type that in the calculator, negative 22 plus 7 does give me negative 15. And so that is the answer. So x equals 22 is going to be my answer for the first question. And then over here, we had subtraction. We wanted x by itself. Now notice again, it's over here on the right side, and that's okay. We want to get x by itself. We were subtracting 5. So in order to use inverse operations, in order to get x by itself, I need to add 5 because negative 5 plus 5 is going to give me 0. That's what's going to allow me to mark that out. But if I added 5 to this side, I must also add 5 to this side. Type in negative 10 plus 5 into your calculator, and you get negative 5 as the answer. And so our goal is to ask ourselves, is it true then that negative 10, again, I'm just rewriting this first line here, is it true that negative 10 is equal to negative 5 minus 5? And if you type in your calculator, remember using the minus sign as a negative, negative 5 minus 5, you do get negative 10. And so that worked out. Now, if you don't get the right answer, then of course you need to go back and check, but your final answer here should have been x is equal to negative 22 and x is equal to negative 5. And that is how you solve one-step equations using addition and subtraction in order to solve. Your practice will be very similar to this. Make sure you use that calculator. It's on the main page. You can always just Google Desmos Scientific Calculator as well. It's also on your Schoology page underneath the agenda. And email me if you have questions.